Okay, SenZi, a sentiment lexicon for the Latinized Arabic. So we've got only 15 minutes. Okay, how did this term come from, and what's Arabizi, right? So it's a mixture of Arabic and Inglesi, which means Arabic and English. It's a transcription of the spoken dialectal Arabic and Latin script. And they not only use the Latin script letters, but they also use numbers to express some phonemes that exist in Arabic but do not exist in Latin languages, such as this word Habibi with the number 7. So how did it start? With the rise of the digital communication in the internet. The early keyboards lack the Arabic keys on the keyboards. So bilingual Arabs, and mainly the youth, found a way to text their dialect using the Latin script keyboards. Okay, a bit about Arabic. It's ranked the number 5th most spoken language in the world. It's spoken with over 400 million people. However, it's not one language for all, because there are a lot of varieties of Arabic, right? So basically it's divided into these categories. We have the modern standard Arabic, which is formal, structured, it's rich in grammar and linguistic rules, it's used in poetry, it's written and spoken. As for the dialectal Arabic, it's esoteric to different regions, as you can see. Like in every region, there's a different dialect, and it differs a lot from one region to another. And it's only spoken, so that's the way Arabs are brought up, using this dialectal version of Arabic. It differs from the modern standard one by the pronunciation, by the tempo of the speech, by the word choice, and it's largely influenced by other countries. So to say the Lebanese Arabic, for example, is influenced by Turkish and French. And what's Arabizi? Arabizi basically is a reflection of the spoken dialectal Arabic and Latin script. It's not used to express modern standard Arabic, right? So just a quick background about Arabizi. Like, how did people come to type Arabic into Latin script, although the languages differ a lot? So the Arabic language contains a lot of phonemes that do not exist in Latin script. People started standardizing different ways to express these phonemes. So we have the guttural phonemes, such as the Ain and Ghain, Ha and Kha from the guttural, and the glottal stop, such as Lu'a. So there were different standardization across countries. For example, in one country they would use the number with an apostrophe or a compound letter. In another country they would use another number. And there are the heavy and light phonemes. So we don't just have, for example, T. There are a heavy T and a light T, such as ta, ta, sa, sa, da, ba, ka, ka. And this is even worse for dialect, because even one letter is used to express 3 distinct letters. We also have the short vowels and the long vowels. Now, the short vowels, the more common ones, are not expressed as letters. They are diacritics. They are marks above or below the letters. However, they're not written in majority of the text on social media. Reason is Arab natives, they know how to read it without the diacritics. And those are important for reading because they are vowels. As for Arabizi, the vowels are really optional. You can write it or you cannot write it. You can still read the text. It's readable. This is kataba, which means write. So what's happening over here? We have an inconsistent orthography. This language, it literally lacks a consensus of how to write words. So what challenges come out of inconsistent orthography and other stuff? First, we have the word ambiguity. If there's the word darb, for example, how would a machine know that this means root or hit? Because it could either be with a heavy phoneme da or da, or a light phoneme da. And this causes lexical sparsity. So every word can be now written in lots of variations. If we were to compile a list of words, like even though if you compile a big list of words, how can we match this list of words in the input text if every word could be written in a long sequence of variations? Arabizi, as to Arabic, is rich in morphology. So for example, I love you, you love me, she loves them, I don't know what. All of these are single words, and this could go up to 100 forms. Now imagine these 100 forms, each one of them could be written in different orthographic variances. This is even enlarging the lexical sparsity. Code switching, very common. This is a famous greeting in Lebanon. Hi, kifak sava. That's 3 languages in just a hello sentence. And this is very usual. So this is a sentence over here with code switching. It's a tweet. Okay, so before we go ahead and process this script and do sentiment analysis, one might ask, how about you transliterate it back to Arabic and then you work with it? And it was quite difficult because of these challenges, the dialect, the inconsistent orthography, the word ambiguity. But we tried it anyway. So we took this tweet, which means, oh, your beauty and your sense of humor, and we put it on Google Translate because it has this option of transliterating. Now, before I show you what happened, transliteration is there, however, it's used online. So if somebody's typing, it would give you a list of words for every word you type, and then you choose which one is the correct word. But anyway, this is Google Translate. It gave us inside you camel and demolished you. So yeah, thank you, Google. You're pretty useless today. All right, so that's our pipeline for sentiment analysis. Data collection, we create a sentiment lexicon, we evaluate. Pretty simple, straightforward. We start with streaming live tweets in the boundaries of Lebanon using the geographic information with the tweets to the API. We extracted 97K Latin script tweets, so we filtered out the Arabic ones, and we pre-processed them, and we took 30,000 for annotation, for manual annotation. We created a user-friendly annotation platform that asks each user whether the tweet is written mostly in Arabizi, and then if they answer yes, it's going to ask them another question, what is the sentiment of this tweet? So they have 3 options to choose from. Is it positive, negative, neutral? And we added them the option to always answer, I don't know, for the ambiguous tweets, whether it's Arabizi, what's the sentiment of the tweet. So we had 3 students for this annotation, and the results were, out of 30K tweets, we had 4.3K only Arabizi. So now we took the ones that 2 students agreed on. There are 3.4K tweets, consisting of 1.2K positive, 1.4K negative. And then again, we took the ones that 2 students agreed on the sentiment. We balanced the data set. We had a data set of 800 positive and 800 negative tweets. And we also took another data set of Arabizi yes and Arabizi no. We also balanced it, and this is going to be used for Arabizi identification data. So this is the sentiment lexicon summarized in this page. Briefly, it's been created over a series of translation and transliteration and manual annotation. We had 3 resources in hand. We used 2 English lexicons, the Who lexicon, the MPQA lexicon, and we were able to get a list of dialectal Lebanese Arabic words, but it's not annotated as positive, negative. So we combined the English lexicons, we took the union, we translated them to MSA, the Modern Standard Arabic, automatically using Babla. We fetched all the translated words, and now we have to select which ones are used in the dialect, because there's a massive difference between the Modern Standard and the dialect ones. However, some of these words are used in the dialect. Another selection task was used to find the ones that are sentiment from this list of words. So now we combine the resulting Arabic lexicons and we transliterated them manually as well. So this marks the first birth of this lexicon, SenZi, containing 2K Arabizi words, 600 positive and 1.4K negative. All right, evaluation. A simple direct forward lexicon-based approach, which is basically it takes the tweet, scan it, skim it, checks if the words exist in the lexicon, and scores the words if it's positive, positive, negative, negative, and aggregate the scores at the end and classify accordingly. So we used a two-class classification on the data set that contains 800 positive, 800 negative tweets. The tweets that were not given a sentiment class were randomized for either positive or negative. And this is the first results. We had only 0.57 as an F1 score, which is horrible. Bad SenZi. Okay, we did some evaluation. Now, it's very important to mention over here that we weren't able to compare this work to other works because this is, up to our knowledge, is the first sentiment lexicon specific for Arabizi, specific for the Lebanese dialect. And even to mention, majority of the people in the literature, they would say, they would filter out Arabizi and would say this is noise. So we looked at these sentences that, the tweets that were not classified to see what's going on, yeah? We can check this tweet, for example. It says, you deserve the success of the world because you spread the happiness everywhere. Congrats to you and your loved ones for all these successes. Now these words, the positive ones you can see over here, they do exist in SenZi, but in another forms, not in the forms they were written. So we are back to the problem of orthographic variations and the rich in morphology. Such as we had successes, in the lexicon it was success. And we had congrats, in the lexicon it was written differently. So we needed to expand SenZi, and we tried a lot of ways. We tried regular expressions, but this was dull. We had the idea to use word embeddings. The intuition was if we can get hands on a large Arabizi corpus, and it's an under-resourced language, by the way, this is difficult. Train an embedding space and have the vectors and check if we input the SenZi words, what are the nearest word labels that we can get out of the word embeddings. So we wrote a script that collected Facebook tweets and replies in public Facebook pages. We selected pages that are highly active and full of comments. We, similar to the Twitter data collection, we skipped the Arabic comments and took the Latin script ones. We pre-processed the comments. We had 2.2 million comments over 49 pages. Now, these 2.2 million Latin script comments, I want to emphasize that they're not only in English or Arabizi. We found that there are other languages, such as French and Latinized Far Eastern languages, Hindi and Filipino. Now we needed to select the Arabizi ones from them, but here's a screenshot of how a Facebook conversation goes in Lebanon social media. So the first comment, as you can see, it's Arabizi, and then in English, and then Arabic, and then again Arabizi, and then Arabic, and this is just a single conversation. This is very usual in Lebanon. All right, how do we select the Arabizi ones? We trained an Arabizi identifier using the data set which contains Arabizi yes, Arabizi no. Now this data set was, we took the agreed tweets from 3 annotators. We trained an SVM classifier with 10-fold cross-validation. The classifier did excellent in classifying and identifying the Arabizi tweets with a F1 score of 0.97. Now obviously one might say, okay, but this is too much, maybe your classifier is not tolerant to noise. That's true, but it was sufficient for the job. So it selected 1 million Arabizi comments. Awesome, now we have our corpus for word embeddings. We trained the embedding space using the fast text library by Facebook. And now our intuition is, let's take 50 nearest word neighbors and see what happens from the SenZi lexical words. We have this word as an example, which means tasty or cute. It's a positive word. And interestingly, all the words that came out from the word embeddings are related somehow, either syntactically, morphologically, or orthographically. But not all of them. So we need to select the ones that are related to the input word. So what we did was a nice trick over here, that we took the sequence of consonant letters and matched them with the words. So in this case, it's TYB, and any word that contains the sequence, we hypothesized that it's related to the input word, and true, it did. So it gave us back all the related words for this one that's used in this corpus. Alright, we did this expansion twice, recursively. So the first one, let's say it got us this sequence of words, and then we applied the same thing for the retrieved words. But using for the selection, we use the parent word for the sequence of consonant letters. This expanded the lexicon from 2K words up to 12.3K, that's 6 times, and then again up to 24K, that's twice. So now we have a better version of SenZi. We did the same evaluation, lexicon-based sentiment analysis over the same data set that we tested it before, and we had a significant increase in the F1 score by 15%. But also, there's nothing to compare our work to, so we did a deeper error analysis. We checked from from the analysis that majority of the error was also not finding a sentiment class for neutral tweets, for sentiment tweets, sorry, saying that they were neutral, though they are either positive or negative. So this is the distribution of error. Form not in the lexicon, similar to the first problem. Although the recall was increased by 25%, but still, because the language is so rich in morphology and each morphologic variant can be written in different ways, the lexical sparsity is so high. The other type of errors was that the sentiment words were written in different languages, such as English. And we had a lot of common expressions, such as happy birthday, miss you, love you, and even swear words as well. Neutral words classified, this could be because the neutral words are contextual. They pose different meaning in different contexts. Multi-word expressions and sarcasm, and this is so common in Arabic dialects. Over here we have the goat drives better. No sentiment word. This is also so common in the literature. So this tweet means there's no more oxygen. We had only 6% from the sample that we took. It's 200 tweets that the actual sentiment word is not in the lexicon in any form at all. The rest, word ambiguity and wrong negation, were small percentages, but they're written in the paper. All right, so just to conclude, all our resources are going to be put up on this project. They're free of access for anyone to use and to test them. And as a future work, we are going to explore cross-lingual word embeddings, especially in Latinized languages. And this can be used for other Latinized languages as well. It's common for Greek, they have the Greeklish. For Farsi, they have the Persish. I don't know what they call it. Finglish, that's true. Anyway, I really want to thank the annotators, the system developers, and the anonymous review for their fundamental contribution. That's it. Thank you, Habibi. Thank you so much.
Thank you.